Ever wish you could ask your codebase questions and get instant spot-on answers? RAG Retrieval Augmented Generation makes that possible. Today, we'll dive into how RAG is revolutionizing code search, making it smarter, faster, and way more useful than traditional tools. So what's RAG? It's a method combining retrieval of relevant info with AI generation. Instead of just searching keywords, it fetches context from your codebase and then crafts a precise answer. This means fewer dead ends and more accurate results when hunting bugs or exploring code. Here's the basic architecture behind RAG for code search. First, the retriever scans your codebase to find relevant snippets. Then, the generator, usually a large language model, takes those snippets and crafts a natural language response. This two-step process is what makes RAG so powerful. Why use RAG for code-based search instead of just grep or basic search tools? Because RAG understands context, can summarize complex code, and even help with code explanations or refactoring suggestions. It's like having a smart teammate who knows your entire repo inside out. You might be wondering, when should you use RAG for your codebase? Great question. It shines when debugging tricky issues, onboarding new team members, or exploring legacy code. Plus, it can generate code snippets or documentation based on your entire repo's knowledge. The key takeaway here, RAG combines your code's knowledge with AI's understanding to transform code search from frustrating to fluid. Next up, we'll dive into how to build your own RAG system for your codebase, step by step. Ready? Let's get into it. If you want RAG magic, you need a solid retriever to find the right bits of code fast. Today, we'll break down how to index your codebase and build a retriever that serves relevant snippets in milliseconds. Let's make your code searchable like never before. Indexing your codebase means breaking it down into manageable pieces like functions or classes, then embedding those pieces into vectors. These embeddings let your retriever quickly find relevant code by similarity, not just keyword matching. This is the foundation of RAG search. Here's a quick example using OpenAI embeddings to vectorize a Python function. Notice how we convert the code text into a vector that represents its meaning, ready for similarity search. Once you have embeddings, you need a vector database to store and search them efficiently. Popular options include Pinecone, Weaviate, and Face. They let you do fast nearest neighbor searches, so your retriever can find the closest code snippets instantly. Here's a simple Python example showing how to query a vector database for your codebase. We pass in a query embedding and retrieve the top matching code snippets by similarity score. Quick tip: to improve retrieval quality, keep your chunks small but meaningful, update your index often, and use hybrid search combining keyword and vector search. These tricks help your retriever deliver laser-focused, context-rich code snippets. To sum it up, a great retriever is the backbone of any RAG system. You've seen how to break down code, embed it, and query with vector databases. Next, we'll plug in a powerful generator to turn those retrieved snippets into clear, actionable answers. Retrieving code snippets is awesome, but what if your system could explain or summarize those snippets? That's where the generator, usually a large language model, steps in. Today, we'll see how to turn raw code into clear, helpful answers your team can actually use. The generator's job is to take the retrieved code context and produce a natural language response. This could be explaining what a function does, suggesting fixes, or even writing new code based on the snippets. It's the AI brain interpreting your code base. Prompt design is crucial. You want to feed the LLM retrieved code plus a clear question. For example, explain what this function does. A well-crafted prompt helps the model focus on the important parts and deliver precise, useful answers. Here's an example prompt you might send to the LLM with a retrieved function. Notice how the question guides the model to explain the code clearly. And here's a sample response from the LLM. It clearly explains the function's purpose in simple terms. This is exactly the kind of output that helps developers quickly understand code. Quick comparison. You can either fine-tune an LLM on your codebase or rely on smart prompting. Fine-tuning offers more tailored outputs, but is costly. Prompting is flexible and easier to start with, especially when paired with retrieval. To wrap this up, integrating an LLM as your generator transforms raw code snippets into understandable answers. This combo makes code search not just about finding info, but truly understanding it. Next, we'll explore how to combine these pieces into a seamless RAG system. You've learned the pieces retriever and generator. Now, let's connect the dots and build a full RAG pipeline for your codebase. This system will let you ask natural language questions and get detailed, relevant answers in seconds. Here's the flow. You enter a question, the retriever searches your vector indexed codebase for relevant snippets. Then the generator digests those snippets and crafts a clear answer. This pipeline repeats for every query, giving fresh, context-aware responses. Here's a simplified Python example tying everything together. We embed the query, retrieve snippets, then pass them plus the question to the LLM to generate a response. One challenge: your codebase might be huge and LLMs have token limits. To handle this, chunk your code smartly, prioritize most relevant snippets, or summarize chunks before feeding them to the model. This keeps answers focused and prevents overload. If you want to skip building from scratch, tools like LangChain, LlamaIndex, and Weaviate offer frameworks to build RAG pipelines quickly. They handle indexing, retrieval, and LLM integration, so you can focus on customizing your code search experience. To wrap this up, a full RAG system combines retrieval and generation to deliver powerful code search and explanation. In the next video, we'll explore how to improve and customize this system with feedback loops and advanced techniques. Want your RAG code search to get smarter every day? Feedback loops are the secret sauce. Today, we'll see how to gather user feedback, retrain your retriever, and fine-tune prompts to continuously improve relevance and accuracy. Start by collecting feedback from developers using your system. Simple thumbs up, down, or comment forms can reveal when answers miss the mark or shine. This data is gold for tuning your models and indexing strategies. Use feedback to retrain your retriever's ranking model or update your embeddings. For example, you can fine-tune embedding models to better capture your codebase's unique style and terminology, boosting retrieval precision. Feedback also helps refine your prompts to the LLM generator. Adjusting phrasing or adding examples based on real queries can make explanations clearer and more helpful, reducing confusion and improving developer trust. Advanced retrieval tricks include hybrid search, combining keyword and vector, query expansion using synonyms, and context-aware re-ranking. These techniques squeeze more relevance and context out of your code search results. To sum up, feedback loops and advanced retrieval techniques make your RAG system smarter and more reliable over time. In upcoming videos, we'll explore real-world integrations and scaling strategies to handle massive codebases and teams. Got a massive codebase or a big dev team? Scaling your RAG system is critical. Today, we'll cover sharding your index, caching, multi-user setups, and maintaining performance as your code and team grow. Sharding splits your vector index into smaller parts based on repo sections or projects. This reduces search space per query and speeds up retrieval. You can shard by directory, language, or modules depending on your code structure. Caching popular queries or partial results avoids repeating heavy retrieval and generation steps. This boosts response time for common questions and improves user experience, especially in team environments. For teams, you need access controls, so users only see code they are authorized for. Implement authentication and permission layers in your RAG system to maintain security and compliance. Monitoring your RAG system's health is key. Track query times, error rates, and accuracy metrics. Set up alerts to catch issues before they affect your developers' productivity. Scaling your RAG system means smarter indexing, caching, secure multi-user support, and monitoring. Master these and your code search will stay fast and reliable, no matter how big your team or repo gets. Curious how top companies use RAG to supercharge code search? Today, we'll explore real-world case studies showing how RAG improves debugging speed, onboarding, and documentation at scale. Let's see the magic in action. Cursor.ai uses RAG to power their AI-assisted code search, enabling developers to query entire repos in natural language and get instant, relevant answers. This cuts down debugging time drastically and helps teams ship faster. At Microsoft, RAG powers internal tools that help engineers understand legacy code and generate docs on the fly. This reduces the time spent reading old code and makes collaboration smoother across teams. A fast-growing startup used RAG to onboard new hires faster by letting them ask their code-based questions in plain English. This reduced ramp-up time and boosted developer confidence early on. These case studies prove how RAG transforms code search from a chore into a powerful productivity tool. In the next videos, we'll dive deeper into customizing and extending RAG systems for unique team needs.